In this video, you are going to learn the process of finding the top 10 percentile of the salary in a given scenario, right? So we have a problem here. It reads like this. Assume that the salaries of workers in a factory in the United States are normally distributed with a mean of 45,000 and a standard deviation of 3,000. A survey was distributed and sampled 75 workers. Let X be the salaries of workers in a factory. What is the cutoff salary for workers in the top 10 percentile? Okay. So to solve this problem, I have a formula here. It says Z is equal to X minus mu over sigma divided by square root of n. And what are these? This X is the variable of interest. That is, you are going to find that particular number. What is the salary of the top 10 percentile? It is that thing you are going to find. Mu is the mean. You can find where is the mean. You have it here. Standard deviation in this scenario. N is the sample size and Z is equal to that Z score. And we are going to refer to a chart to find that what is the Z score in this particular case. Alright. So let me also show you a visual. We are looking for this number over here, like at this point, what is the salary? From here, everybody on the right side, you have the top 10 percentile, right? So that's what you are looking for. So I'll go ahead and write down the given information. So first thing is this one, that is mean, right? Mu is equal to 45,000 and sigma, the standard deviation is 3,000 and the sample size is 75. So this is sigma, standard deviation, and the sample size, the number of workers who are surveyed is 75. And this X is the thing you are going to find, right? X is equal to how much? And in order to get this Z score, I have to go to my Z chart. That is, what is the value here in this top 90 percentile with reference to this top 90 percentile? What is the Z score, right? To get that, I'll go to my Z chart. I have it here. Alright, let me show this once again. My Z chart gives only the right hand side values, like as you know. So 90 percentile is here. From this whole normal distribution, 90% here and 10%. This is our concentration. But 90%, that is 90 divided 100, which is equal to 0.90. Where is this point, 0.90, in my Z chart? That is my task to find. So try to locate 0.9. See, as you start from here, 0.5, 0.6, 0.7, 8, and 903249, etc. I am seeing this number closer, 0.9015, and even 0.8997. This is only 3 units below 9000, and this is slightly greater, right? 15 is more. So let us consider this number. What is the corresponding z-score for that 0.8997? I'm coming all the way here, that is 1.2, and go upwards. This is 0.8, matching with that. So what is the value of the z-score? It is 1.2 and the 8th column. So I will write 1.28. That is my z-score. So z is equal to 1.28. Now it's very simple. In step 1, you identified what is what and then got those values of everything within this formula. And now we are going to just substitute and simplify to get our value of x. What is x? You are going to find. So let me bring this formula here. We will substitute all the known values in this formula. I'll start off with z. Z is equal to how much? 1.28. Remember, we got it from that z chart. Identified what is that 90 percentile, right? That's this 1.28 you have. X, I don't know. Mu, the mean is 45,000. I'll divide this by 45,000. Okay. 45,000 divide sigma, that is 3,000. 3,000 divide square root of n. N is 75. So let me write down 75 here. Now, this is basic simplification. Once you have these values substituted within this formula, only this x is not known. This is the x. I have to isolate this x from the whole of this equation. So let us do it carefully. So what is the first step in this? We'll try to eliminate, remove this 3,000 divide square root of 75 from this denominator, right? So as it is dividing here, what is the inverse operation? You know, it is multiplication. So I will multiply both sides by square root 3,000 divide square root 75, I should say. And this side also, on the right side I did 3,000 divide square root 75 multiplication. Same thing I will do on the left hand side, that is 3,000 divide square root of 75. So I can do that. So by doing so, this is cancelled. The denominator, the difficult part is taken care of. So now what is remaining? I have 3,000 divide square root of 75 times 1.28. Feel free to put these things in parentheses so that it will avoid confusion. So x minus 45,000 on the right hand side. Now only one thing is remaining extra on this right hand side. What is that? Minus 45,000. And I want to cancel that. Do the same thing again. The inverse operation. Subtraction you want to cancel. So I will do the addition. Plus 45,000. What happened on doing this? This negative 45,000, positive 45,000 got cancelled. So everything is gone from this, right? Only this x is isolated. You have This denominator got cancelled and the minus 45,000 also cancelled. Only x is remaining on the right hand side. Alright. So I'll write down x here. X is equal to, what do you have there? It is 3000 divide square root of 75 times 1.28 plus 45,000. Alright. Now what I'm going to do is, I'll just use a calculator and enter everything into my calculator and find what is the x value. Alright, I'm using Horn Desmos calculator, a scientific one. So on the top, that is 3000, right? 3000 divide square root 75, then come out, times 1.28 plus 45,000. So what is the answer you have? 45,443. I am rounding it to the nearest dollar. 45,433. So let me just snip it. Alright. So this is what you have. Now this x is equal to, right, the value of x is equal to $45,443. This is telling me that the cutoff salary for the top 90, other way around, the cutoff salary for the top 10%. See, I use 90, that's why I was saying 90. 10%, the top 10% is this one. Okay. And let me also show you graphically here. On this, I have, these are the salaries, right? You have mean of 45,000, standard deviation 3,000, divide square root of 75. You can get this answer using Desmos graphic calculator, but you are expected to do it using this Z chart. So that is the purpose. And here you see after 45,000, this thing 45,400 and 33 or something is there. No? This is the point that you are looking for. Okay. So I hope this helps. How do you find the x values in this given scenario? You have a mean, you have standard deviation, the sample size, your whatever value you are looking for, whether it is top 10% or 5%. If it is 5%, I'll go to that 0.9500. So that's how you can answer these problems. Thank you so much.